Hey everybody, welcome to my next video lesson. In this video lesson, we're going to take a closer look at 3 of the laws of thermodynamics. The first law that I'm going to talk about is called the Zeroth Law of thermodynamics, and the reason it's called the Zeroth Law is because it actually came later than the other laws, but they put it at the beginning because it's so fundamental to our understanding of how thermodynamics works. Basically, the Zeroth Law of thermodynamics says that if you have 2 objects that are in contact with one another, but they are not the same temperature, one will transfer its energy to the other until they're both at thermal equilibrium. Now, thermal equilibrium is important because we're not talking about the same amount of energy, we're talking about the same amount of temperature. And so let's say object A is 70 degrees and object B is 50 degrees. Well, they will both change temperature until they are equal temperatures. We don't know exactly how much heat A gives to C because we don't know what mass A is as compared to C, as we talked about in the last video, how heat transfer has a lot to do with how much of the substance there is. But we do know that A and C will eventually become the same temperature. And then if you add a third object, well, B will become the same temperature as A and C as well. And so no matter how many objects you have, all of various temperatures, they will all eventually achieve equal temperature or thermal equilibrium. Imagine you put a can of pop from the refrigerator and a hot cup of tea from the microwave on top of a countertop. Well, the countertop is room temperature, the hot tea is hot, and the cold soda is cold. But eventually, all 3 objects will become the same temperature, and that's the Zeroth Law of thermodynamics. The first law of thermodynamics, which is actually the second, but you understand, we call it the first law of thermodynamics, says that in any isolated closed system, energy gained by a substance must be equal energy lost to another. Now, we talked about this a little bit in our first module when we talked about the law of conservation of energy. That is exactly what we're talking about here. The first law of thermodynamics is the law of conservation of energy. But because it's a law, typically what we have is a mathematical relationship to kind of back it up. And that's what this is showing. It says that if an object gains energy, well then the energy that it gained is equal to the energy lost from the surroundings. If the object loses energy to the surroundings, well the energy gains the same amount of energy lost by the object. And so this applies in both cases of endothermic and exothermic situations, where the energy gained is equal to the energy lost. That is the whole concept behind law of conservation. But we don't say it's an equal loss, equal gain, because gaining means there's positive energy, but losing actually is a negative value, right? Exothermic energy lost by the surroundings equals energy gained by the system, where the system is the thing that we're observing, and the surroundings might be the water that the substance is dissolving or reacting in, or maybe it's the air. But in order to reconcile this, we need to mess around with the signs a little bit. So instead of saying energy gained equals energy lost, we say energy gained equals negative energy lost, because it's lost by the system. So numerically speaking, the magnitude of these numbers is the same, but the sign has to flip. So if an object gains 150 joules of energy, then the surroundings have to lose 150 joules of energy. And that is the law of conservation of energy, or the first law of thermodynamics. Finally, we're going to talk about the second law of thermodynamics. And there's actually multiple parts to the second law of thermodynamics, so we're going to just isolate one part which talks about the flow of heat. Basically, what we see here is an animation that is unable to be shown because this is a PDF and I can't show the animation. But let's just say you have an object that has high temperature over here and you have an object that is of lower temperature over here. The second law of thermodynamics says that energy always flows from high to where it's lower until the 2 objects become equal temperature. Once again, we call that thermal equilibrium. So the second law of thermodynamics says that heat will always flow from high to low. Just like water always flows downhill, heat always flows from high to low. So in chemistry, we actually don't really ever talk about something being cold. We say that it's lacking in heat. This kind of keeps things consistent, and you might think that's weird, but it actually makes things more simple. So you have something with high heat and you have something with low heat, and the energy goes from where it's higher to where it's lower until they have equal temperature. So there's no such thing as cold in chemistry. Well, that takes care of this video lesson. Thanks for watching.